Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our today's class. Our today's topic is chemical equation and balancing of chemical equation. I think you have already known about the chemical reaction and the chemical equation. The chemical reaction is the process in which new substances with new properties are produced. Okay, and the chemical equation is the short expression of chemical reaction. The short expression of chemical reaction using symbols, formulas and different signs like a plus sign, equal sign and arrow mark, etc. So to understand the chemical reaction and chemical equation, we have to know about two terms, which is reactants and products. Reactants and products. The substances. What is reactant? The substances that are needed to begin a chemical reaction is known as reactant. Okay. The substances that are used to start our chemical reaction is known as reactant, and the substances that are produced during the reaction with new properties are known as product. And now we can start with the chemical reaction, and this is the statement: hydrogen gas and chlorine gas combine to make hydrochloric acid. This is a sentence. This sentence tells us about a chemical change. That means a chemical reaction, and this presentation is known as word equation. Okay, these types of sentence presentation is called word equation of the chemical reaction. And we can use this word equation to write any chemical equation. Let's try to write the chemical equation from this word equation. Okay, hydrogen gas. We use the formula of hydrogen gas. Which is the formula of hydrogen gas? We know about that. Hydrogen, H2. Okay, and means plus. Okay. For chlorine gas, chlorine diatomic, because it's a non-metal, reactive non-metal gas. Okay, gas molecule, and combine to make represent arrow sign. Is represented by arrow sign. Okay, these two combine to make a new compound, which is hydrochloric acid. Okay, this is the formula. This is the formula of hydrochloric acid, and this equation is known as chemical equation. This is the word equation for this chemical change, and this is the chemical equation of this chemical reaction. Okay, and there are some rules observed to express to write chemical equation in order to express any chemical reaction. Okay, and first of all, the reactants are written on the left side, and the products are written on the right side. Okay. These two are reactants. Hydrogen for this chemical reaction, hydrogen and chlorine is the reactants, and HCl totally different from these two elemental molecule, and the properties of HCl is totally different from chlorine and hydrogen, and this HCl is product for this reaction. Okay, and if we have more than we have to express, we use here the formulas of each compound and elements, and between if we have more than one products and reactants, then we have to put plus sign between them. Okay, we have to add the symbol with a plus sign. Okay, and between product and reactant we have to put a arrow mark. That means reactants are on the right side, products are on the left side, products are right side, and in the middle a arrow sign, or sometimes equal sign. Sometimes the physical states of both products and reactants are mentioned in the chemical reaction, chemical equation, and this physical state are written at the right side, of the product or reactant, element or compound, and within a first bracket, and if the physical state is solid, then we put S, and if the physical condition is gas, then we put G, like that, chlorine gas, like that. Okay, and produce HCl gas. That means we have the physical state in short form are written at the right side of the elements, formula of the element, and keep it within a first bracket. And for if the physical condition is liquid, then we have to put small l within first bracket, and if the substance is in aqueous solution, then we have to put a q within first bracket. And for any exothermic or endothermic reaction, if the equation is to show how much heat has been produced or absorbed in a chemical reaction, then the equation has to be balanced, and the physical state of reactants and products are to be written. Okay, for example, what is exothermic or endothermic reaction? You will learn about that the next chapter, the chapter 7 about chemical reaction. But now I can define it easily like that. The exothermic reaction is the reaction in which heat is produced with the product. Okay, and the endothermic reaction is the reaction in which heat is absorbed from the surroundings during the reaction. Okay, and for this type of reaction, the reaction must have to be balanced, and the physical state also are to be written like this, and the amount of heat absorbed and evolved will be mentioned with this equation. Okay, and suppose, for example, we can write an example, the ammonia production. Okay, nitrogen gas. Okay, and hydrogen gas. We have to take hydrogen, nitrogen and hydrogen gas. When it reacts with each other, then ammonia gas is produced, and this is the exothermic reaction. Heat is evolved. This is 92 kilojoule heat is involved here. Okay, and for this reaction, this is also gas. We have to mention gas within first bracket, and this reaction must be balanced because this amount. If the reaction is not balanced, then this value can be varied. Okay, and for this we have to balance this, put it 2 and here 3. Okay, that means for these 3 types of reaction, balancing is the very important, and balancing is must. But the main objective of any to write any chemical equation is just show the reactants and products of the chemical reaction. Okay, and for that it is not necessary always to balance a chemical reaction. Okay, but when we want to be very accurate, then we can we can try to balance the chemical equation. Okay, and sometimes there are some reactions that requires heat to be applied. Okay, and then we have to put a delta sign. We have to put a delta sign, okay, above the arrow sign. Okay, and let's see an example. If we take calcium carbonate, okay, calcium carbonate, limestone, and this is solid form. The physical state of calcium carbonate is solid. If we heat this calcium carbonate, it is shown by this delta sign. Okay, and we get calcium oxide as a solid form, and carbon dioxide gas is released. Okay, if we heat the calcium carbonate, solid calcium carbonate, we get solid calcium oxide and carbon dioxide gas. Though in a chemical reaction, reactants and products are different substances, but they are made of the same atoms. Okay, and that's why for a chemical reaction the law of conservation of mass is followed. Okay, the law of conservation of mass is followed for chemical reactions, and that means the number of atoms of each element on the right side, left side, and that means reactant side, and the number of atoms in the right side will be same, always will be same. And that also means the total mass of the different atoms and of the reactant side, and the total mass of the atoms of the different elements of the product sides will be also same. And that's because the atoms, we know atoms cannot be destroyed, or atoms cannot be disappeared or created also. Okay, and that's why the law of conservation of mass is always obeyed for chemical reactions. And this is called the balanced equation. That's why this equation is called balanced equation. And so what is meant by balanced equation? The balanced equation has same number of each type of atom on both sides of the arrow. This is the arrow, and the arrow sign also shows the direction of a chemical reaction. Okay, and that means reaction proceeds from left to right. These are reactants, and after the reaction produce product. Okay, and that means the same number of each type of atom. That means here nitrogen and hydrogen, the number of nitrogen and hydrogen atom always will be same, which are present in this ammonia. We can balance the chemical equation using following some steps, and we can balance the chemical equation making a simple chart, and doing a little bit of math. And we can take a equation. In this equation, nitrogen and hydrogen atoms are present and on the both sides of the reaction. Okay, and now we are going to make a chart. Okay, make a simple chart, and in which we will write the number of atoms which are present in both sides. Okay, number of hydrogen and nitrogen atom which are present in both sides. And let's start. This is our equation. This is very important equation. Nitrogen and hydrogen reacts with each other and produce ammonia gas. Okay, and for here we on the right side nitrogen gas is present, N2 is present. That means 2 nitrogen are present on the right side, and H2, 2 hydrogen is present in the left side. A very important rules for balancing the chemical equation is we can only change the coefficients. We can only change the coefficients, the numbers in front of the atoms. Okay, and we cannot change the number after atoms, the subscripts. Okay, the subscripts, because the subscript tells us how many atoms are present in of a given element in a molecule. In a molecule, it is participated, this number, this subscript number is participated in the formula to write the formula of, express the formula of any molecule. Okay, that's why it cannot be changed when we do the balance. Okay, and but coefficients, the coefficients tells us how many molecules are present in the reaction. Okay, and we here the number of nitrogen atoms is 2 and the number of hydrogen atom is 2, and for product here after arrow ammonia is present, 1 ammonia is present, 1 molecule, and here 1, that means 1 nitrogen atom is present and 3 hydrogen atom is present. Now for balancing the equation we have to look at where we have the imbalances. Okay, imbalances, and that means where we don't have the same number of atoms. Okay, then and we can observe here at first nitrogen, here nitrogen is 2 but here only 1. So now we have to think what number, by what number we can, which number we can multiply those elements, those compounds. Okay, and we can balance them. Then if we multiply, if we put 2, if we put 2 here, then we get 2 nitrogen, and now our nitrogen is balanced. But this is a formula, and if we multiply 2 here, then we have to multiply these 2 with this subscript number, and that means 2 is also times the 3 hydrogen. Okay, and 2, that means 6 is equal to 6. Now our nitrogen is balanced, but the hydrogen atom still unbalanced. Okay, and that's why now we have to choose another number, which is, this is 2, this is 6. If we multiply this, we put as a coefficient 3 here, then we get hydrogen 6. Okay, now show like that, 3 is equal to 6. Now look at this chart, nitrogen 2, 2 balanced, hydrogen 6, 6 balanced. The total number of right side, left side and right side are equal, and this is called the balanced equation. And students, this is all for today. In our next class I will discuss about more about this balancing of equation. That's all for today. Assalamu alaikum.